Hello everyone, in our last video we introduced stoichiometry and talked about molecular weight. Since finding the correct molecular weight of a molecule is really important to stoichiometry and building relationships throughout our time in chemistry, I want to focus this video on doing some practice problems with molecular weight. Throughout these problems, I strictly want to focus on finding the molecular weight. There might be some other questions, but throughout this video, we're just going to focus on finding the weight of the molecules for each of these examples, starting off with 2,3-difluorobutane. This particular molecule has 8 hydrogens, 4 carbons, and 2 fluorine atoms. So what we're going to do is we're going to reference the periodic table and find the atomic weight of each of these atoms. Because there's 8 hydrogens, we have to multiply that value by 8. Carbon by 4 and fluorine by 2. We take the sum of all those additions and multiplications and we get 94.064 grams per mole for 2,3-difluorobutane. You're first starting off learning how to formulate the molecular mass. It's really important that you double check your work, because as we find the molecular weight of a molecule, we're going to rely on that number or that weight for multiple relationships or other problems. So if that answer isn't correct, the other ones are going to fall. Next question, we're going to do the exact same thing as we did with the previous question, but in this case we're going to find the molecular weight for ielto methane. In this case we have 3 hydrogens, 1 carbon, and 1 iodine atom. We're going to multiply the atomic weight of hydrogen by 3, then add the weights for carbon and iodine to get the molecular weight for ielto methane, which is about 142 grams per mole. Quite interesting, because we can say that 2,3-difluorobutane had more atoms than ielto methane, but because some of the atoms in ielto methane were heavier, at the end of the day the molecular weight of this molecule was heavier. I know that seems a little intuitive, but it's really cool to look at. All the weight of ielto methane is really coming from that one iodine atom. Next two problems that we're going to look at is for methoxy ethane and 1-propanol. This is where finding the molecular weight is still important, but sometimes the relationship fails to tell us more about the molecule. For example, both methoxy ethane and 1-propanol have 8 hydrogens, 3 carbons, and 1 oxygen atom. So in the eyes of molecular weight, both of these molecules weigh the same amount, 60 grams per mole. This is the limitation of finding the molecular weight. It doesn't tell us anything about how the atoms are connected. Here we can see that methoxy ethane and 1-propanol have that oxygen atom placed at different positions in their molecule. The reason why I wanted to show this example is to introduce to you that all these tactics and relationships we build never show us the full picture, and always have a limitation or two. Our last question, I'd like to find the molecular weight for ethylamine. And after we find the molecular weight, I want to show how important it is to finding the number of molecules if we have a certain weight of ethylamine. Well, as we done before in the previous problems, we had to look at our molecule, identify the type of atoms. In ethylamine, we have hydrogen, carbon, and nitrogen. Then we have to identify the amount of each of these atoms. In the case for hydrogen, we have 7. In the case for carbon, we have 2, and nitrogen 1. Then we have to refer to our periodic table to find the atomic weight of these atoms. In the case of hydrogen, it's 1.008, and then we multiply that by 7. For carbon, 12.011, we multiply that by 2. And since there's only 1 nitrogen, we just add the 14.0071 grams per mole for nitrogen. Then we sum all that up to get a total weight of 45 grams per mole for ethylamine. Let's look at that very first relationship that's built after we find the molecular weight. We want to convert how many grams are in 3.02 millimole of ethylamine. After converting to the base unit moles, we can see how reliant this conversion is on the correct molecular weight for ethylamine. If it was different, we would get a different value for the amount of grams. Even in the second question, when we have an amount of grams but we want to convert it to the number of molecules. In this case, we're using the flip of the orientation, a certain amount of grams of ethylamine to the amount of moles. But if the molecular weight was wrong, this conversion would be wrong too. This is to show how important molecular weight is. It has its limitations, but moving forward, it's something that we're going to do time and time again to know more about our molecules. Well, I hope this step-by-step and in-depth review of molecular weight helped with your studies in general chemistry. If you liked videos like this, I can definitely do more in the future. And remember, all these graphics that you see throughout this video are free digital download over on my website. And I wish you guys a good day.